Dear students, that is the fourth lecture of linear algebra. Today we will start chapter number 2. In chapter number 2, we will learn that how could we solve the system of linear equations. This topic has been studied in your previous classes, but in algebra point of view, we will study the structure of these kinds of equations in the form of rows and columns. So first of all, we'll study that what is a linear equation. As we all are familiar with the definition of linear equation, that an equation in which the highest power of variable is 1. For example, if you look at these two equations, x equal to 1 and y is equal to 1, that is the first equation. In this equation we see that the highest power of variable is 1. So this is linear equation nx in one variable x. And if you write y is equal to 2, so note the power of y, this is 1, so the highest power of variable y is 1, so this is again a linear equation in y. As there is only one variable y, so this is again a linear equation in one variable. So these are two linear equations in one variable. Secondly, if you see here, this is a single equation in which two variables are involved, and the maximum power of variables in this equation is 1. The power of x is 1, the power of y is 1. So this is a linear equation in two variables x and y. Similarly, if you see here, so this is again a single equation, and the degree of each. This third equation, this is a single equation in which three variables are involved, and the powers of these variables are 1. So this is a linear equation in three variables x, y and z. So this is how we understand the idea of a linear equation. Secondly, we are talking about the system of linear equations. System means if there are more than one linear equations are given to you, more than one linear equations, so we say that this is the system of linear equation. For example, just look at these two equations. X minus 2y is equal to 1. That is the first linear equation. And 3x plus 2y is equal to 11. That is the second linear equation. If you see, I write here row picture. Row picture means that is the first row and this is the second row. So the first row shows a line, whenever you draw the graph of x minus 2y is equal to 1, so that will look like that one. X minus 2y is equal to 1. This is the equation of a straight line. And whenever you draw 3x plus 2y is equal to 11 in row form, so you will get this kind of graph, linear graph. Remember that the graph of a linear equation always represent a straight line. So this row 1, I mean this first equation, represent the first straight line, and the second row, I mean the second equation, linear equation, represent this second line. We see that these two lines intersect each other at this point, and this point, if you look at this point, the value of x is 3 here, and the value of y is 1 here. So x is equal to 3, y is equal to 1 means that these two lines intersect each other at a single point x comma y, 3 comma 1 here. So the row picture of these two linear equations show that a two lines intersect each other, meet each other at a single point, and that single point is the solution of these two equations. So that is the row picture of these two equations. If I note that the row picture shows first row, second row. The row picture shows two lines meeting at a single point x comma y in 2D plane. Now we are studying here linear equations in two variables, so that's why x comma y 2D plane, which is the solution, this point is the solution of these two given lines. The point of intersection of two lines is the solution of those two linear equations. So that is the row picture of these two lines. Now secondly, we are talking about the column picture. The column picture combines the column vectors on the left side to produce the vector b on the right side. What does it mean? It means that if you go backward, just look at this equation. This equation comes from those two linear equations. Let me go back. These two linear equations. You see here, if you take x common from this column, taking x common, so 1 will be left here and 3 will be left here. So x into 1 3 plus, if you take y common, so that will be just like minus 2 2 is equal to 111. This slide x 1 3 x times one vector, column vector, plus y times another column vector is equal to right hand side column vector. So this is called the column picture. The first column into x, second column into y, when combine each other, when adding these two to get the right side, vector b. This vector b is actually the right side, 111 column vector. So that is the row picture, that whenever two column vectors join, they produce a single column vector, 111. Now how could we add two vectors? We have studied that two vectors will be added in a sense that we complete a parallelogram whose one side is this vector, second side is this vector, and the sum of these two vectors is actually the diagonal of that parallelogram or rectangle. So that is the diagonal, actually. That is the diagonal, because this vector is the sum of these two vectors. So that is the column picture. You see here, this 1 3 vector is this 1 3 vector. X is 1 here and y is 3. So 3 and 1, that is 1 3 vector. That is the position vector of 1 3 point. And the second one is minus 2 2. Minus 2 2, x is minus 2, so x is minus 2, and y is plus 2, so y is plus 2. Plus 2 and minus 2, that is the position vector of minus 2 2. And the solution, which number should be multiplied here with 1 and 3 and with minus 2 and 2 to get a sum of 111. So whenever we have studied in the previous slide that the solution of these two equations is 3 1, means that x equal to 3 and y is equal to 1. So whenever x is equal to 3, so 3 times 1 is 3 plus y is 1. 1 times minus 2 is minus 2, so 3 minus 2 is 1, and 3 times 3, 3 3s are 9, plus 1 times 2, so 1 times 2 is 2, 9 plus 2 is 11. 1 3 is actually the solution of this thing. So that's why multiplying this vector by 3, multiplying this vector by 3, 3 times column 1, this is column 1, 3 times column 1, so 3 times this vector, that is 3 times this vector, so that is just like 1 times, 2 times and 3 times. 3 times this vector will increase the magnitude of this vector 3 times. 1 times this vector, it means that the magnitude of this vector will not be increased because 1 times something is that time. So 1 times minus 2 into 2 is the same vector, so the length of this vector will not be increased, that is the same length which is given to you. So now complete this parallelogram, or you may say that this rectangle, whenever we complete this rectangle, we will get the diagonal from the origin. The diagonal from the origin is B, this is B. So if you look at this B, this point is, in this point x is equal to 1 and y is equal to 11. Count these bars, so those bars are 11. So 111 is the diagonal of this rectangle, and this diagonal is actually the resultant vector in column notation, 111. So that is the column picture. The column picture of two linear equations is a combination of columns produces combination of columns produces the right side 111, produces the right side 111. That is the column picture. So the column picture deals with vectors, and row pictures deal with lines, planes, and so on and so on. Anyways, that is the column picture of these two equations. So the linear combination, this is actually 3 into 1 3 plus 1 into minus 2 1. This is the linear combination of these two vectors. The linear combination of these two vectors gave us a single vector, which is actually the diagonal of rectangle, thus obtained. Now welcome to linear equations in 3 variables. The row picture of linear equations and 3 unknowns, when 3 variables are there, show 3 planes meeting at a single point. That is the first linear equation in 3 variables. So that is the first row. That is the first plane, you may say that. Secondly, this row is the second plane. You may consider plane as a page of your copy, a page of your register. That is a plane actually. So that is the first plane, the first page. That is the second page of the copy, and that is the third plane. So the row picture of these 3 equations involving 3 variables shows 3 planes, plane 1, plane 2, plane 3 meeting, 3 planes meeting at a single point. If you take 2 pages and if you take 2 pages and you just like in this fashion, you insert one page into the second page, just like that thing. First page, that is second page, so they'll meet at a single line, and that is the third plane. This third plane will pass when you insert a third plane here, so that plane will intersect this whole line, which is the meeting line of these two planes. So this third plane will meet this single line at a single point, this single point. So the intersection of two planes is actually a straight line, and whenever a third plane is introduced, so that third plane will intersect this line of intersection of these two planes at a single point. I am repeating this sentence, that two planes intersect at a single line, and a third plane will intersect that single line, that whole single line, at a single point, so that single point is called the solution of these three planes. So row picture, I mean row 1, row 2, row 3, these are three planes actually. Row 1 is the first plane, row 2 is the second plane, that is the third plane. These three planes intersect or meet at a single point, this single point. Now what about column picture? If you see here, taking x common, so 1 2 6 will be left here, and take y common, so 2 5 3 will be 2 5 minus 3 will be left here, and take z from this column common. There is z, but that is missing. Okay, there is z, so taking z common, will be left 3 2 1 is equal to 6 4 2. So combine three columns. What is the column picture of these three equations? The column picture of these three equations is just like that one, and it represents that the linear combination of three vectors or three columns produces a single vector, 6 4 2. This picture, that is the picture of 1 2 6. The first vector 1 2 6 lies in the space. If you draw this vector, that will lie in the space, and draw a position vector on this point, so that is the position vector of this point, 1 2 6. Similarly 2 5 minus 3, so whenever you draw this 2 5 minus 3 and draw a position vector on this point, so that is the position vector of this point, that is column 2. And 3 2 1, this is 3 2 1 from here up to there. 3 2 1 is the position vector of this third vector. 6 4 2, now 6 4 2, when you draw 6 4 2, so that is this vector. You see here, if you multiply 2 with this vector, so 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2. So 2 times this vector is actually this vector. It will increase the length of this vector. Anyways, so column picture x y z, you see here, if we solve these three equations, we will get x equal to 0, y equal to 0, z is equal to 2. So x equal to 0, y is equal to 0, z is equal to 2 is the column picture of these three vectors. The linear combination of three vectors which give us a resultant vector, column vector, is the column picture of 3 linear equations. So it means that the whole story is that whenever we look at the row picture, so it will mean that there will be 3 planes meeting at a single point, and whenever the column picture is there, so it will mean that the linear combination of these 3 vectors, which give us a 4th vector, is the column picture of 3 linear equations. Now this slide is about the questions, and I consider those questions which are related with this topic. Question number 9, 10, 11, 12, 13, the coming exercise of your book. The question is, compute each AX by dot products of the rows with columns, with column vector. We have studied that how could we multiply 2 matrices with the help of dot product of rows and columns. So how could you multiply? This first row dot this first column is the first row of the resulting matrix, and this second row dot this column is the second row. Similarly, the third row dot this column is the third row. So we will compute this is actually matrix A, and this is actually matrix X. Similarly, this is A and this is X. So how could we compute this product? By dot product, taking the dot product of rows with columns to get a resultant vector. Question number 10 is about the computation of AX in problem 9 as a combination of the columns. Write those products in the form of column vectors. How could you write these 3 in the form of combination of columns? That is very simple. You can do that. And question number 9 becomes, that is just a hint is for you people, 2 times the first column plus 2 times the second column plus 2 times the 3 times the third column is equal to what? So that is actually the combination of columns. That is a hint for you people. Actually, that is a hint for you people. Question number 11, find the 2 components of AX by rows or by columns. That is a very simple question. How could you find the 2 components of AX by rows or by columns? Now question number 12 is the same as before. Just leave this question number 13 because this is MCQ type of thing. You can do that, but a bit thinking is there. We will discuss this afterward, inshallah. Question number 29. Start with the vector u0, 1, 0. Multiply again and again by the same Markov matrix. What is Markov matrix? Markov matrix is a matrix which is used in probability theory. The property of Markov matrix is the sum of the entries down any column is 1. The sum of the entries in the column is 1. It means that 0.8 plus 0.2 is 1. The sum of the entries in the column is 1. 0.8 plus 0.2 is 1. 0.3 plus 0.7 is 1. So this is this kind of square matrix. Square matrix. What is a square matrix? The number of rows equal to number of columns. So a square matrix in which the entries in the column, the sum of the entries in column is 1, is called Markov matrix. So this Markov matrix A is equal to 0.8, 0.3, that is the entries in the first column. Then colon is there, and these are the entries in the second column. Just look at this, the entries in the first row column, the entries in the second row, second row. That is u0, u1, u1. The next three vectors are u1, u2, u3. A is given to you, u0 is given to you. Multiplying this A with u0 to get this u1 vector. Now obtain u2 by multiplying this A with this u1 vector, and obtain u3 by multiplying this u2 with A to get u3. What property do you notice for all above vectors u0, u1, u2 and u3? So discuss that property. Question number 34. Start from the four equations. If you put I equals to 1 here, you will get one equation. Then put I equal to 2 here to get second equation. Then put I is equal to 3 here to get third equation, and then fourth equation. With x0 and x5 equal to 0, write those equations in their matrix form. That is, ax is equal to b. Right, this side will be a and x, and that side will be b. Can you solve them for x1, x2, x3 and x4? That is question number 34. So this Markov matrix is used here. And secondly, what is a pivot element? The first non-zero element of a row is called its pivot. If you look at the first non-zero element of a row, so the first non-zero element of a row is called the pivot of that row. Just look at this matrix. This is first row. In the first row, this is the first element which is non-zero, so the pivot of this row 1 is 2. Similarly, the pivot of row 2 is 1, and row 3, this is row 3. The first non-zero element is 1, so this non-zero element is the pivot of this row. Similarly, here this is row number 4, and in row number 4 this is 0, this is 0, this is non-zero, so the first non-zero element is 1, so the pivot of this row 4 is 1. So that is the story of pivot element. And now we will study the solution of system of linear equations by elimination method. This is very important topic, that how could we solve system of linear equations by elimination method. So the first thing is we need to convert the given system of equations to upper triangular form. Upper triangular form. How could we convert the system into upper triangular form? The first step is we need to eliminate x, then y, then z to get upper triangular matrix. So when we eliminate x first, then y second, then y z third, we will get an upper triangular matrix. And then we will use back substitution. What is back substitution? From last equation. Back substitution will start from last equation to get z in the reverse order, to get z, then y, then x. So that is the back substitution method. So by conversion of upper triangular matrix, upper triangular form, if you are asked to solve the system of equation by converting it to upper triangular form, you need to eliminate x, then y, then z to get upper triangular matrix, and then use back substitution from the last equation to get in the reverse order z, y, and then x. So let us start an example. Example is that solve the systems using back substitution. So it means that we need to convert the system into upper triangular form. And the second part is identify the pivots as well. So that is a matrix ASA. We have just studied that is row number 1, and the first non-zero element of row number 1 is 1. So this is the pivot of row 1, which is 1. Similarly, the pivot of row 2 is 2, and the pivot of row 3 is -1. So these are two questions. This question is about two equations and two variables, and this is three equations and three variables, and we need to use the back substitution. So back substitution means we need to convert up to upper triangular form. We need to eliminate x first. So how could, if we take this first part, we need to eliminate x from these two equations. How could we eliminate x? If we multiply equation 2, I name this equation 2 and this is 1. If we multiply equation 2 by 2 and then subtract it from 1, this x will be eliminated. So that's why I multiply equation 2 by 2. This whole equation is multiplied by 2. So that is 2x minus 2y is equal to -4, and write equation 1 here, plus 2x plus 3y plus 1, and subtracting these two. Whenever you subtract two equations, we will change the sign of these terms. So plus will be minus, this plus will be minus, and this plus will be minus. Now subtracting, 2x minus 2x cancel, minus 2y minus 3y is minus 5y, minus 4 minus 1 is minus 5. Now that is an equation which is obtained by eliminating x from these two equations. So we are left only with one equation in one variable. Now we have the following equations. Take this first equation, or you may take the second equation, but usually you take first equation. 2x plus 5y is equal to 1, and this resulting equation minus 5y is equal to minus 5. So just look at this system. This system is just like in this form. Above this diagonal, this is non-zero, and below this diagonal, this is 0. This portion is 0. So this is the upper triangular form. This kind of form is called upper triangular form, and the pivots are, the first non-zero is 2, the first equation, the first non-zero is 2, and from the second equation, the first non-zero is minus 5. So these are the pivots. The diagonal elements are the pivots of those two equations. Now we'll use back substitution. Back substitution means we'll start from the last equation. Equation number 3 implies dividing this minus 5 to that side. So y is equal to minus 5 by minus 5, so y is equal to 1. And then taking equation 1, above equation, put this value of y in equation 1 to get the value of x. So the solution is x equal to minus 1 and y is equal to 1. So that is solution. That is the solution obtained by using the back substitution. That is a very simple question to solve. Now second part is about three equations in three unknowns. We need to use back substitution to solve these three equations. So back substitution means we need to eliminate x first, then y, and then z. So eliminate x, then y, z will be obtained. How could we eliminate x? If we multiply equation 1 by 2 and subtract it from 2, so x will be eliminated. And similarly, if we multiply equation 1 by 3 and subtract these two, x will be eliminated. So the answer is, we need to multiply equation 1 by 2, so that will be 2x plus 2y plus 2z is equal to 4, and equation 2 is written as it is. So equation 2 implies 2x minus y minus z is equal to 1, 2x minus y minus z is equal to 1. Now subtracting these two, so subtracting means change those signs, plus will be minus, minus will be plus, and this minus will be converted to plus sign. Similarly, this plus with minus sign. Now subtracting these two, 2x minus 2x cancel, plus 2 plus y is 3y, plus 2z plus z is 3z, and 4 minus 1 is 3. Now dividing this equation by 3, so we'll get y plus z is equal to 1. Similarly, multiplying equation 1 by 3 here, multiplying equation 1 by 3, 3x plus 3y plus 3z is equal to 6, and write third equation as it is below this equation, and subtracting these two by changing the signs to get 3x minus 3x cancel, plus 3y minus 2y is y, and plus 3z minus 5z is minus 2z, 6 minus 5 is plus 1. So that is equation number 5. Now just look at these two equations. X is eliminated. Now eliminate y from these two equations. How could we eliminate y from these two equations? Just subtract these two equations. Equation 4 minus equation 5. This is equation 4, this is equation 5. So because we are going to subtract these two, so change the sign. Plus will be minus, minus will be plus, plus will be minus. Now y minus y cancel, plus z minus 2z, plus z plus 2z is 3z, 1 minus 1 is 0. Dividing by 3 to get z. Now that is z. Now we are interested in back substitution. So back substitution means find z first, so z is obtained. Now put this z in equation 4r5 to get y, so y is 1. Now put this z and this y in either of these equations, this equation, that equation, or that equation. This equation is simple enough, so putting y and z in this equation to get the value of x. So that is the value of x equal to 1, y equal to 1, and z is equal to 0. So that is the back substitution method to solve the system of linear equations in 3 variables. This example is very important because in this example we'll study that whether the solution of equations is possible or not. Find the solution, if possible, of the following system of equations. There are two equations, namely two questions. That is the first question and that is the second question. We need to find the solution if possible. So first of all, we have taken these two equations, equation 1 and equation 2. By using the elimination method, multiplying this equation 1 by 2. So equation 1 by 2. 2 2s are 4, 2 3s are 6, 2 2s are 4. And writing this equation 2 below this equation and subtracting these two. Subtracting these two, plus x plus 4x minus 4x cancel, plus 6y minus 6y cancel, so 0 is left here, is equal to 4 minus 1. 4 minus 1 is 3. Is it possible 0 equal to 4, 0 is equal to 3? It is not possible. So it means that solution does not exist. So if this kind of situation arises, that 0 is equal to some non-zero number, it means that there is no solution for that system of equations. Now just look at these two equations. That is equation 1 and this is equation 2. multiplying equation 1 by 2 to get 4. So multiplying equation 1 by 2, 2 2s are 4, 2 3s are 6, 2 2s are 4, and writing equation 2 below this equation and subtracting these two, we'll get 0 is equal to 0. So 0 is equal to 0 is possible, and this is true for all values of x and y. Whatever the value of x is here, whatever the value of y is here, this equality holds. So it means that there are many solutions, there are infinitely many solutions in this case whenever 0 equal to 0 arises. Whenever 0 equal to a non-zero situation arises, so it means that solution does not exist. Whenever 0 equals to 0 arises, so it means that the system has infinitely many solutions. Pronounce this as infinitely, not infinitely. Infinitely many solutions. So how could we obtain those solutions? 0 is equal to 0. So if you multiply y with this 0, so 0 into y is the same 0. So 0 into y is equal to 0. What will be the value of y here, which is multiplied with 0 to give 0? What is that special value of y? So I may say that this y may be negative. Negative multiplied by 0 is 0. Positive real numbers multiplied by 0 is 0. 0 itself multiplied by 0 is 0. So this y may be any real number. This y may be any real number. Let's say I choose y is equal to c. So c is actually a real number. Now y is equal to c is 1. Put this y in equation 1 or equation 2. Whenever you put y is equal to c in equation 1, we'll get 2x plus 3c is equal to 2. 2x plus 3c is equal to 2. Transferring 3c towards that side to get 2x is equal to 2 minus 3c, and dividing this to that side to get the value of x. So solution is x is equal to 2 minus 3c by 2, and y is equal to c is the solution. Now if you change the value of c, if you replace c by 0 here, you will get one solution. If you replace c by 1 here, you will get second solution. If you replace c by minus 1 here, you will get third solution. So replacing c by any real number will give you infinitely many solutions for these two equations. So as a special case, if I choose y is equal to 2, c is 2. That is not necessary, but I'm just taking this special case. For example, if y is equal to 2 here, so it means that c is equal to 2. So replacing c is equal to 2 here, we'll get x is equal to minus 2. So one of those all solutions is x equal to minus 2 and y is equal to 2. X is equal to minus 2 and y is equal to 2. That is one specific solution among those infinitely many solutions. So remember that if 0 is equal to 0 case arises, it means that the system has infinitely many solutions, and whenever 0 equal to a non-zero number situation arises, we'll say that the solution does not exist. There is no solution for that system. So that is the topic for about today's lecture. So I think this, just look at the last slide. Question number 1. What multiple L21 of equation 1 should be subtracted from equation 2? What does it mean? What multiple L21? It means that equation number 1 should be multiplied by a number to manage these coefficients. What multiple of equation 1, this equation 1, should be subtracted from equation 2? So if we multiply this equation by 5, so that will become 10. So this L21 is actually 5. 5 should be 5 multiple 5 of equation 1. Multiple 5 of equation 1 should be subtracted from equation 2 to get an upper triangular system. So L21 is equal to 5. 5 should be multiplied here to eliminate x. After this elimination step, write down the upper triangular system and circle the two pivots. Whenever you multiply this equation by 5 and subtract these two, you will get an upper triangular system. So circle the two pivots. The first pivot will be 10 after multiplying by 5, and the second pivot will be of 10 after subtraction. The number 1 and 11 have no influence on those pivots. Anyways, you just need to circle out the pivots and elimination should be there. Question number 2, solve the triangular system of problem 1. You need to solve the system. How could you solve the system? By back substitution. So it means that you need to find the value of y first and then put back the value of y and equation number 1 to get the value of x. So that is question number 2. Verify that x times 2 comma 10 plus y times 3 comma 9 equals 1 comma 11. X times 210, 210, taking x common from 210, so x times 210 plus y times 39 equals 1 times 11. Whenever you find the value of x and y, put the values of x and y over there to verify that the answer, the resulting vector is 111. If the right side changes to 4 and double 4, 44. If we change this side to 4 comma 44, it means that 1 is multiplied by 4, 11 is multiplied by 4, we will get 4 comma 44. So it means that the solution which is obtained, the value of x and the value of y should be multiplied by 4. So that is equation 2. What multiple, that is the same question as this one. Question number 4, what multiple L of equation 1 should be subtracted from equation 2 to remove C? How could we remove C here? We need to multiply the first equation by C by A. C by A. A will be cancelled out, so C will be left here. So the multiple L in this case is C by A. The first pivot is A, assume non-zero. Elimination produce what formula for the second pivot? Whenever you multiply this equation by C by A, you'll get Cx plus BC by AY is equal to F. So what will be the second pivot here? X will be eliminated and the coefficient of y is the second pivot. Choose a right side which give no solution and another right side which give infinitely many solutions. What are two of those solutions? So the first thing is choose a right side which give no solution. So if you see here, if you multiply this equation by 2, so that will become 6, and when you subtract these two, x will be eliminated, and when you multiply this 2 by 2, so that will be 4y, minus 4y will be 0 here. So what number should be chosen here to get no solution? So no solution, if you multiply this equation by 2, it will become 20. Now whenever you subtract these two equations, we will be left on left hand side 0. So the right hand side must be a non-zero number. 0 equal to non-zero means no solution. 0 is equal to 0 means infinitely many solutions. So for no solution, choose this number in order to subtract these two to get a non-zero number. You may choose any number, and for infinitely many solutions, choose this side, that number which give you 0 here. 0 is equal to 0, infinitely many solutions. What are the two of those solutions? Then find the two specific solution by choosing the values of y, two values of y, 1 minus 1, maybe 0, maybe 2, maybe 3, maybe 1 by 2, and so on. So those all questions are of this type. Question number 6, 7, 8, and 9 are of that type. Question number 12, reduce this system to upper triangular form by two row operations. We need to convert this system to upper triangular form, this form, just like that. X, then x is removed, y is removed, z, this form. Circle the pivots and solve by back substitution. That is the same question as this one, and that one. So that is the whole story about this lecture. I hope there is nothing else to worry about this topic, because that is an older topic which you have studied in the first year course. Best of luck.